Welcome back. Today we're going to be looking at TensorFlow in Python. And you're probably wondering what TensorFlow is, but it's a machine learning platform that is completely open source, and it contains all sorts of tools to do all sorts of different things. Interestingly, TensorFlow is not just Python. It also works in C++ as well as other languages such as JavaScript. So it's not Python specific, and that does mean that if you do something in Python, it is possible to use it elsewhere. We're going to start by importing everything, and you can see that TensorFlow is almost synonymous with Keras, which is a large part of TensorFlow, and we've also got some other libraries for other things. And you may need to install TensorFlow, but how you do that depends on your operating system, so have a look at their website for how you're going to do that. Next, we're going to download the MNIST dataset, and we can see the shape of it. And here, because they're stored as integers, we have divided them by 255. And you can see that y has labels and x is 28 by 28 images. Next, we want to find out the classes, and because these are just digits, they're a list of the numbers 0 to 9. And you can see a few random ones here. So you've got numbers 0, 5, 5, 1, and 0. And that's what they look like. So now we're going to classify them, and we're going to build a sequential model by stacking layers. So you see the first thing we do is we set our device to CUDA, although TensorFlow does this automatically, so we don't have to worry too much about it. You can see that our model starts with a 2D convolutional layer that's shaped 28 by 28 because that's the size of the image. Then we max pool, we flatten everything, and then do classifications. And you can see that we haven't specified the input size for anything other than the first layer, and that's because it works it out automatically for you, which is very nice. Next, we're going to be using this sparse categorical cross entropy, and as you can see here, it takes a vector of logits and returns a true index, which means we might give a number a 5 as a label, and that's a sparse way of having a list of the numbers 0 to 9 and setting the 5 number to a 1. Next, we need an optimizer, and you can see we're using Adam with a small learning rate because it's quite a small model. And while 265,000 trainable parameters seems like a lot, it's surprisingly few compared to many other models. Now we need to compile it, and this is going to just save it onto the GPU, as well as specifying some metrics. So we're going to look at accuracy and a loss function and an optimizer. Next, we need to fit the model. So this is saying we have our train data and our train labels, and we're going to just train it for 2 epochs with a 64 batch size, and then we just wait for it to run, and we can see that it's going to go through each epoch and optimize the parameters. And you can see it's finished with about 97.5% accuracy. And so we can then do model evaluate, and we look at our test set, which we haven't seen before. And you can see this is the loss, 0.7, and this is the accuracy. So again, about 97.5%. So now we can create a probability model, which is a sequential model which takes in the model and then a softmax at the end. And this means that we're returning probabilities rather than logits. We can also then save the model to model.h5, and we can then just load it back. And then we need to compile it again. And it says here the model was not compiled, and that's because here we never called model.compile on our probability model before we saved it. You can again see the summary, and you see it takes in a sequential model, and all it cares about really is the output shape, and then this softmax. And we can now make predictions. And so we run it on 5 random ones, and so this is a 2, which is correct, this is a 5, this is a 3, this is a 5, and this is a 1, it is. So it's been quite simple to create a model. We haven't had to specify too much, just the type of model we want, how it's constructed, and then some of the metrics, some of the optimizers. And it has been very little work, but it's been very effective. And we can now use our model for some kind of handwriting recognition. For example, if we wanted to recognize handwritten digits. So hopefully you've seen that Tensorflow is a great library. It's very good for machine learning. And if you want to do machine learning, you can choose between this or PyTorch, whichever one you feel suits your use case better. So hopefully you've enjoyed this video, and I'll see you again same time next week. Till then.